In outcome 4, we started talking about probability. So the first thing that I want to review are just some probability basics. Remember that all probabilities have to be between 0 and 1. So if you get a probability that's 1.5, you know you did something wrong. Probabilities are always percentages, and the largest percentage we can have is 100%. We talked about this non-existent, quote, law of averages. What this says is that if an event hasn't happened in a while, it doesn't change the probability of that event happening. For example, you might be sitting here rolling a dice, and so you might say, I haven't rolled a 5 in a while, so the chances of it happening are higher. This is not true. The chances of you rolling a 5 are still just 1 out of 6 because there's still those 6 sides of your dice. With probability, we are very big on notation, so make sure you are good with all of these notations here. This first one is just the probability of A. So A is our event. We're finding the chances that A occurs. The next is called our complement rule, or we sometimes just call this not. So this would be the probability of not A. That little dash up top means not. Or they could use a little c as their exponent as well. Again, this is the complement, which means the opposite or not A. Next, we have the probability of A or B. That little u there means or. Probability of A and B is that or sign turned upside down. And then the last notation is this conditional probability. So that straight bar up and down, this says that we're finding the probability of A given that B occurred. We also talked about disjoint or mutually exclusive events. If two events are disjoint or mutually exclusive, it means that they have no outcomes in common. So they cannot occur together or they cannot happen at the same time. For example, I could have, when I'm looking at cards, picking a red and a black card. These would be mutually exclusive because there's no card in the deck that I could choose that is both red and black. If two events are independent, this means that the two events have no impact on one another. So I could roll a die and then I could pick a card from a deck of cards. Whatever I land on that dice, it has no impact on what I pick in the cards. So those would be independent events. Okay, in this first section of probability, we also talked about these at least problems. We tend to struggle with these ones. They are kind of tricky. Whenever we're finding the probability of at least one or at least something, you're going to take 1 minus the probability of none. So you're going to subtract the probability of that thing not happening. Okay, I have a quick example here for us. It says if I roll one dice 5 times, so I'm going to sit here and roll the dice 5 different times, find the probability that I land on tails at least 1 time. Now, to help us visualize what's happening with these at least one problems, I like to make just off to the side a quick diagram where I'm going to list my sample space. So I'm rolling this die 5 times. It's possible that I don't land on tails at all, so my first option is going to be 0 tails. It's possible that I land on tails once. I'm going to put 1 tail. I could have 2 tails, 3 tails, 4 tails, and I'm only rolling it 5 times, so 5 tails would be the maximum. So this right here is my sample space. I remember that this sample space, the probability of each of these events in my sample space always has to add up to 1. So what I'm looking for here is the chance that I land on tails at least 1 time. So that would be 1, 2, 3, 4, or 5. So I'm really looking for all of these. Now I can find the chances of landing on 1, then the chances of landing twice, and 3 times, 4 times, 5 times, and add them all together. It's a little bit easier here to use our complement rule, which says that if my sample space adds to 1, all I'm going to do is take 1, subtract the chances of not landing on tails at all, so 0 tails, And that will leave me with all of these other options. So we're going to take our sample space that adds to 1. We're going to subtract the probability of landing on 0 tails. So I'm not landing on tails at all. Now on one flip, the chance that I don't land on tails means I'm landing on heads, so that would be 1 out of 2. Sorry guys, just realized that I was saying rolling a dice, landing on tails. It should be flipping a coin. So if I flip a coin 5 times, I'm landing on tails. Sorry about that. Okay, so if I'm not landing on tails, that means I have to land on heads, so that's 1 out of 2. I need this to happen 5 times, so I'm going to put my exponents of 5. And here, I'm going to go ahead and just use my calculator. So I have 1 minus 1/2 to the 5th, which gives me 0.9688. If I round, you could leave your answer just like that as a decimal, or you can change it into a percentage. Either one would be totally fine. So again, I recommend always writing out that sample space and then taking 1 minus the probability of 0.